Welcome to PPI Conversations, an opportunity to connect with leading edge thinkers and leaders and discuss today's pressing topics in the engineering and construction industry with your host, PPI Executive Director Gary Fischer. We at PPI address the root cause of major capital project cost and schedule overruns through the research and dissemination of project production management and its foundation of operations science. Enjoy the conversation.
Well, welcome to another PPI Conversation. I'm Gary Fischer, Executive Director of the Project Production Institute. You know, if you're an owner making a capital investment to generate a return on that investment, do you ever ask yourself, despite all the best of intentions and use of best practices, why can't projects be completed on time and on budget? You ever ask yourself, why you have to put up with this normalized pain? Or why can't contractors do better? Well, there's one visionary that asked himself those same questions several years ago and determined to change the industry. This guy forged a different path that eliminates the pain, provides predictable investment results. I'm here today with that visionary, Todd Zabelle, author of Built to Fail, Why Construction Projects Take So Long and Cost Too Much and How to Fix It, published by the Forbes Books. Welcome, Todd. Let's get the ball rolling and start by telling our audience about why did you write this book?
Well, that's a great question, Gary. Thanks for taking the time to do the interview. Really three things, believe it or not. And I just turned 60 this year, so maybe that's part of the story. But you know, the world has a huge opportunity in what we're doing with basically a whole nother form of how we're going to be living. And that has to do with digital transformation, energy transition, and even the modernization of the civil works, right? The numbers are quite staggering, as you've probably heard many times. Build the equivalent of a Paris every week or New York every month when it comes to buildings, right, on the floor plate. Probably talking right now about $500 billion per annum on digital transformation. And all that is the tail wagging the dog of what McKinsey now estimates to be $9.2 trillion per annum of CapEx for energy transition.
Wow.
Excluding the mining for all that, right? So the numbers are staggering, the opportunity is huge, but yet the industry continues to struggle, right? So we start thinking about, you know, why is the industry struggling and what needs to be done? I have been extremely fortunate in my life to work with the people that I work with. Now, if you go to LinkedIn, you hear a lot of people talking about great people and great this and great that, leadership and teams. I actually have had the opportunity to collaborate and work with the people that are probably, or undoubtedly, some of the most influential people in the global construction industry, right? Martin Fischer and the work he was doing down there in 3 and 4D modeling in the early 90s at Stanford, Boyd Paulson, who was down there running the program, Glenn Ballard from UC Berkeley, along with Iris Tomaline, people I work with in the company, James Chu and Roberto Burlu, through the acquisition of Factory Physics, the relationship with Mark Spearman. These are really leading thinkers that understand what needs to be done to solve this problem, to enable this vision of energy transition and digital transformation. So I just started thinking, I've had this unique experience, and why not just put it all together and put it out there that people can take a look at, and they could debate it or they could buy into it either way. It's for them to decide.
Yeah, excellent. So any particular contribution from those folks that you'd want to highlight?
Yeah.
Had a real impact on you and your thinking?
Yeah, and I'll say a little bit about my story because I think a lot of people go through this story, and you start off, I believe, thinking that it's all about how do I motivate workers to work harder. Yeah. It's like a motivational problem, right? How do I get these people to do more, right? And it's just a natural thing. And you study that, and you know, maybe it's not totally the answer. You then move to what I'd call more of a project management perspective, and I had read many books, thick books, from the aerospace and defense industry about project management, but I was doing direct hire construction work, and I'm like, this doesn't really help me, right? So what began to happen was, in meeting Martin originally, this idea of 4D visualization, we could actually model and visualize operations before we do them. We could work the kinks out before we do them. And that was pretty innovative at the time. And the guys that were working on that were more focused on the strategic aspects of maybe the traffic flows and what building we could build when. I was interested in how do we put the bolt on, the nut on the bolt.
Yeah.
Then through Martin, I met Glenn Ballard, right? And Glenn was deep into production at that point. And this was before the word last planner meant what Glenn calls a production control system was actually just the last person in line, right?
Yeah.
And then beginning to understand the production view, what we were working on at Lean Construction when we founded that in 1997, and then getting into the world of deep operations, what we now call operations science through Mark and Wally and those guys, and really beginning to understand how the production aspects of this are really the important part. So if you're trying to influence time, cost, use of cash, quality, safety, carbon, it all gets down to the production. When you cross the river and you get in that world, you are now in a place of unlimited opportunity, right? So what those people have done and the contributions that they've made to me, they've actually offered to the whole world, right? And I'll just to go a little bit on this, I'm just a little frustrated though when I look at LinkedIn and other things, how people that haven't really truly understand those frameworks have begun to spin them into other scenarios. And so I think that's another reason, maybe reason 3.5 for the book, was to really document what happened.
Put a stake in the ground.
Right.
Yeah.
Right.
Yeah. And before we're going to talk about this in a lot more detail, but how did we get here? How did the construction end up so challenged, flatlined?
Yeah, and flatline, we should put a little more color on that. As the executive director of PPI, we went back a few years ago and we took the work that was done at Stanford on productivity, and we found some other stuff from the National Bureau of Statistics, and we did an analysis of their work and figured out there's been no productivity gain since 1910 in the U.S. construction industry. And the same is true for most industries around the world, right? And it's quite staggering. No gain, no gain, right? As a matter of fact, I was at a conference that McKinsey did a while back, and they actually said in the last 3 years that we've gone even further negative from where we were. That's just staggering to me, but it's not unsurprising. We took that work and we began to overlay it, and we started looking at something that got very clear. It just came off the page. There was what we call era one, the era of productivity, where people like Frederick Taylor and the like were looking at how do we get more out of each worker. Kind of like the journey that I talked about. I was trying to figure out how do I motivate these workers, right? Yeah. Howard translates that for construction, and my argument I'll submit to you is that if you look at a operations manual for a majority of contractors today, there's a lot of that work in there. And I would encourage people to go read that, especially how you can download on Google Books for free. It's quite interesting what they were talking about back then. The big idea there is that if everyone in a process is working as hard as they can, that the work will go as fast as it can, or the work will progress through. We know that's not true, and as early as Ford figured that out. So while Taylor was busy working on his, let's call it scientific management, or as he called it, right? He built upon Babbage from the 1800s. Ford was looking at flow production, right? And didn't invent, but perfected at the time the assembly line to get that even flow. Later, we zoom forward and we see this next era driven by primarily the U.S. Navy around the Polaris missiles and program and some other programs where there's this idea to have predictability, right? Now, who doesn't love productivity and predictability? These aren't bad things to have. These are great things to have. However, how you go about the predictability is interesting. And so we begin to see things like critical path scheduling developed by Kelly and Walker. We see PERT that I think Booz Allen Hamilton did with the Navy. We see stage gate processes. We see earned value management, right? And we get more and more administrative. Now, being here in San Francisco, it was very interesting to see as we move into the late 80s and early 90s, at this point, construction management's becoming more of a part of things. Owners are divesting their engineering departments. General contractors are becoming non-risk CMs as agents of the owner, and then the claims consultant shows up, right? And in a building right across the way here that might be in the video actually, a law firm focused on claims and had a whole stack of people, and they're going around the world doing construction claims. That became an industry in itself, right?
Right.
So what happens? People begin to protect themselves. A critical path scheduling that was designed to plan a project has now become a means for a legal instrument, right? And I'm sure you know as much about this as anybody, right? And then we begin to think about what do we put on the schedule? Do we put what we want for the claim, or do we actually put the work we're going to do, the work we didn't do, or the work we could do, right? It gets very interesting. So I think that gets us to era 2. This group, starting with, as all things start at Stanford, right? Lauri Koskela goes there to do some PhD work from VTT in Finland, and asked us a new production paradigm adopted from what the Japanese were doing, later known as lean applied to construction, and that opened up the beginnings of a view of managing production, which is this idea of era 3, which we call the era of profitability. Why do we call it the era of profitability? Because there's so much waste in the process these days that the owner can get their project done quicker, less use of cash, improving their net present value, however they measure their IRR, whatever the case may be. The contractor can make a significant amount of profit, and we could do the projects faster for less money. There's tremendous waste in the process, and everybody knows that. But we need a different perspective, and that's why we're proposing there's an era 3 out there, profitability.
Okay, and so what, in that era 3, what needs to be done to solve the problem?
Yeah, so it's interesting to look at how we try to use administration to manage work. And I didn't say this earlier, but probably should have. Part of era 1 was the rise of bureaucracy, right? And that bureaucracy really gets, what's the word, ramped up, if you will, in era 2, and this idea of formal project management as we know it today, right? The first thing we need to do is we need to shift the focus from being administrators, right? We used to joke back in the days when I was a contractor, we would say the construction management guys are box checkers, journalists, and submittal stampers, right? And so we need to move from administration to production. And there's a lot of people talking about that, but again, I'm suspect of people that are talking about production. Then we need to bifurcate the schedule from the production system. So to us, and I think this is a really, really important point, if there's one point that I could get across, it is that the schedule is needed, but it creates the demand for the production system.
Okay.
The production system, think of all the entities or resources that do the work. Trucks, drivers, cranes, welders, engineers, computers, so on and so forth, right? Those production systems in their individual configurations exist. So there are steel fabricators that do fabrication of steel and may do the erection or subcontract the erection. Somebody's done the detailed engineering or the shop drawings, right? That's a production system. There's precast production systems, piping production systems. The owner, and typically a construction manager, put together those production systems that are already operating into a temporary production system for a project. Okay, so 1, we've got to move from administration to production. 2, we need to bifurcate the schedule into the modeling of the work we need by who, when, what we need by who, when, and then the idea of the production system being all the entities. Once we then look at the production system separate from the schedule, we can use a different mindset, and I alluded to operation science earlier, and that is schedules work in dates. Production systems work in rates. And any specialty contractor will know this. If you came to me and you at the time you were at Chevron, or if you work for a general contractor or CM, you said to me, I need to have this amount of work done by this date, I immediately figure out how many days I have and divide by how much work I have. And that tells me by hour, by day, how much I have to do.
Right.
So people begin to practice the idea that we have to translate from dates to rates. We can't manage dates. We can only manage the production system and its rates.
That's really significant.
Yeah. So it's incredible when people find they're behind schedule and they're trying to figure out what to do, or when they rebaseline. Rebaseline is just, it's the most interesting thing to me. Schedules are things that today occur in computers that may or may not be related to reality. The production system's 100% reality. Nobody can change anything on a schedule unless it's fake without changing the production system.
Mm-hmm.
Right? Think about that.
Well, this concept of production systems is just so critical. You were a contractor at one time. How did you see this? When did you start seeing this, that production systems exist?
Yeah, and so I met Martin Fischer in 1991. I was working for a specialty contractor in San Francisco, and I thought that for us to make more money, that was that simple, and do more work, we had to figure out how to manage the work better. And so I thought Martin was really onto something with the 3 and 4D modeling, because that would solve a lot of problems for us. We had a lot of coordination problems coming in to do the work, right? And I took that to the people that own the company I work for and said, this is really something we should look at. And they said, we don't really understand that. We don't know where we're going. So I started my own company in 1993 just so I could go play with this stuff. I mean, I really got in the business to go do stuff that I thought was going to make a huge impact.
Yeah.
And as I said earlier, when Martin introduced me to Glenn, then I began to see the world of production. I was fortunate enough that I had union guys working for us. We did fabrication, we did site installation, we managed logistics. So we actually had a real world to play with, right? And so it was quite exciting to go out there, and our typical estimating would say maybe something's going to take 100 man hours to do, and we'd do it in 17, right?
Wow.
But it was a totally different way to look at it. And interestingly enough, we worked many years without a single lost time incident. We were winning quality awards. We had a cost advantage, and people couldn't necessarily understand what we were doing, but it was all about the production. And the men, at that time, we didn't have any women, the craft guys were happy. They were happy.
Why were they happy?
Because we could pay them over scale, number one.
Yeah.
Number two, they were heavily involved in the design of the work methods, right? And got to try new things. So we would invest in finding ways, and I talk about in the book, we would spend a lot of time just to get what I mean by production. We would get different types of, let's say, screw guns and fasteners to figure out which one will work. And people are like, you're crazy. I go, well, if you got to put in 32,000 of these things, it makes a big difference whether it takes 10 seconds or 10 minutes,
Yeah.
right? And so when you really get down to the work element and you understand the work, the opportunity is significant. And I'll just add one more thing while we're on it, somewhat related, and that is, as we look at these production systems, and we do maybe what I'm alluding to here, this idea of production engineering, what we found, which is fascinating, is and I see the lean guys focus on this, they focus on how do I make the activity or the task go faster.
Right.
They might do it in the context of the whole, I'll give them that. Where the opportunity is in the queue between the two tasks or operations. And so it's not uncommon to see a process where the queuing, things are waiting, is up to 90% of the time. So I'll give you an email, right? If you get an email, how long does it take to respond? People usually say, I don't know, well, how long does it take to respond to email?
I don't know. 4 to 12 hours.
To respond.
Yeah.
Actually type it. I'm saying how long to just type the response.
Oh, just a few minutes.
There you have it.
Yeah.
So just divide those and there you have it. So
Yeah.
the actual process time, as we would call it, the time in the box is a few minutes.
Right.
But the total cycle time, you said, is measured in hours.
Yeah.
Right? That's no different if we go in a fabrication shop or a construction site. There's a lot of things queuing. They're in the inbox. And then boom, someone does the work, right? So there's a huge opportunity to have a step change in the finances of projects, because that queuing is the tie-up of cash through work in process, not progress, right? And again, you're going back to your original question, how did I get into this? The more I started seeing this, and I'm just a novice at this. It's quite fascinating because I don't think it could ever end. What you learn when you get into the world of production. But again, it was about moving away from motivating people to work harder, Frederick Taylor, filling out forms and more administration, to getting down to and seeing the production and doing production engineering. How can we design things that are easier to install, easier to maintain? How can we package things a certain way, right? I remember, I'll give you one other quick story. Actually, on the building across the way here, there's a movie theater, and we went to the lumberyard, had everything in 3D measured out for blocking that we had to put in, and they said, if you give us the order, we'll cut all this lumber that you have on these drawings. I said, great. And so they cut all the lumber, we packaged it up, craned it up, and the Carpenters Union went crazy because we had the iron workers install the wood in probably less than half a day. That probably would have took 3 weeks with the saws and all up there in the dust. But then you go back and think about the environmental. Here's a guy at a lumberyard that has all the appropriate stuff to deal with the sawdust. We'd be out here in the Embarcadero Center in San Francisco and causing all this dust and noise and so on and so forth. So the production thing to me has been fascinating, and it really started off with how do we make more money? No other reason. And then start my own company to go play with it.
Yeah. Wow, that's quite a story. So you mentioned a few minutes ago that there was operation science, which drives or how these production systems perform. Why don't you tell us more about that?
Yeah, so that was interesting. We start the Lean Construction Institute, Glenn, Greg, Iris, and me, and we actually had a pretty good relationship with the Lean Enterprise Institute, Jim Womack and Dan Jones, and got to meet them. But yeah, the struggle there was none of those were bad things to think about. They were quite good. They open your eyes up. But how do you really go do this, right? So if you should keep a capacity buffer to absorb variability, what does that mean? What would I go do if I'm a contractor? And so when we went to do Heathrow Terminal 5, and we actually put SPS in business to go do Heathrow Terminal 5, we would invite the best or most respected person in a certain knowledge set in the world. So we invited Mark Spearman to come over, who was with Factory Physics at the time. And he blew our minds. We went from talking about qualitative things about you've got to use single piece flow, and I remember Mark saying you got to be lean, not anorexic, and how do you calculate that? Work in process is the proxy for time, and I just if you don't want to balance a line, you want to have a bottleneck and control the bottleneck like a valve, right? It was just mind bending, and so what happened was we began to get a scientific framework for how to view this production, right? And so it was interesting because, and Mark, we joke around about this, probably my personal contribution in all this was that the idea that we could translate operation science for projects. And today I get this, we don't have enough repetition or one-off, whatever the case would be. Okay. And that actually, if you look at the project as a production system, you can begin to do things that you wouldn't otherwise be able to do. And even Mark was arguing, we had a yelling match on the phone, it was, I don't know, 10 years, whatever. But Mark was really the one that brought the science to the party, right? And once you begin to understand the science and the relationships, it's a whole nother level, right? I mean, it's incredible what you can do.
So how would you summarize the science, or is it possible to summarize the science in a nutshell? Or is there part of the science that's more important than the other part of the science?
Yeah, that's an excellent question, and probably another key point here equal to the production system construct. And I'll tell you some things that we think are important, and then maybe we can contrast those with how construction operates today.
Okay.
All right. So in a production system, it doesn't matter whether we're making widgets or we're in an engineering office, a restaurant, a construction site, it doesn't matter. You can only push so much work into the process before you hit a plateau. Okay. So when you hit that plateau, no more work will go in. Now, typically, a mechanical engineer or an electrical engineer will understand that, because when you tell them if you put too much in there, something adverse is going to happen.
Right.
A production system's no different. Okay. As a matter of fact, the production systems often comprise those fields of engineering as part of them, right?
Yep.
If you're batching concrete or rolling steel, whatever it gets to be. Okay. However, the more that you put in, when you hit the plateau, the cycle time shoots out. So there's a relationship between the work in process, not progress, and time. So if you think about your career, what are people trying to do out there? They're trying to get more work going.
Yep.
Right? And I hear James Huey's been going on about this a lot. I guess he's talked to a few executives who told him, my earned value looks great, but my project's behind, right? And so it's just building more and more WIP. And so you start looking at, so what does the earned value actually reward or recognize? Building more WIP, right? Right. Okay. And from your past, you know about that on some very, very large projects, some of the largest in the world. Second construct that's really important is the higher the utilization, the longer it takes. So if we put a lot of cars on the freeway, we're going to get a traffic jam due to congestion, right? That's cool. Everybody understands that. And again, I'll quote James Chew. Why do the people that go to work at 5 or they go to lunch at 11:07 when the cafeteria opens up, because they know they want to beat that congestion from the traffic, right, are trying to drive up tool time and utilization of the guys on site, right? So we got pushing for more work to get earned value. We've got driving up utilization, and we know the higher the utilization, the longer the wait. And by the way, from an operations science perspective, there's really only two things you could do. You could manage the WIP, or you can manage the capacity utilization, right? And the contributes to capacity, labor, equipment, and space, right? And so at the end of the day, all the scheduling, all the rebaselining, all the motivation, leadership, collaboration gets down to what we call the 5 levers. How you design the product, whether it's the fastener you're going to use with the whole facility,
Right.
the work process associated with it, and those two are interconnected. So if we have precast concrete, that's going to have a different process than in situ, right?
Yep.
So they're interconnected, and we want to take a play out of the aerospace and defense and automotive industry or product development. We want to design the product process concurrently. Well, we're challenged by that, by the desire for people to get competitive tenders. How do we know we're going to get the best price unless we send them some information and give us a bid or a tender? Well, we already know they're not going to give us the best price because we did that, right? And we keep doing that thinking they're going to give us a better price. Then we get down to the other 3 levers. So we said there's the product design, the process design, those two are related. Okay. The other 3 levers are the relationship that we just talked about between capacity, inventory, and I'm going to introduce a new thing, variability. Anytime 2 things together are connected and operate differently, we have variability. If it takes you 5 minutes to do it and me 7 minutes to do it, something's going to build up a queue.
Yep.
If it takes you 7 minutes, or excuse me, if it takes you 5 minutes to do it and me 7, yeah, queue's going to build up. If it takes you 7 minutes to do it and me 5, I'm going to be standing around.
Yep.
Right? That might not be a bad thing. Do we want a queue or do we want a capacity buffer, right? And so what we tend to like in the construction industry, primarily because the way the percent complete accounting works and what we do with the earned value rules of credit is we reward inventory or work in process because it's free. Now, this gets really interesting because if you're a service provider, architect, engineer, specialty contractor, or even a construction management firm, WIP is probably pretty good because you get money. If you're the owner, it's the worst thing because it's messing up your cash flow.
Yep.
It's impacting your NPV, and it does that because it's constraining your ability to get to revenue, right? And so you think about this and say, the whole underlying structure of this thing is based on a flawed model, if you will, whether, again, it's the percent complete. We had a really interesting meeting last week in London, and we were overlaying a stage gate process we started with. We purposely said, okay, we put the stage gate up, and we said, now let's overlay the environmental impact study. And you can see these guys were twitching. Well, we don't really do the stage gate that way. And then they said, we have some regulatory things we need to go through. Well, let's put that, and they're twitching again. And by the time they got done, one guy looked over and said, well, we don't really follow the stage gate, do we? And I said, well, you do, but just they're not your stages and your gates.
Yeah.
They're your stakeholders, right? So there's a lot of stuff out there. So what's happened is the lead time is causing issues. So you just put this together, the percent complete accounting along with the earned value promotes excessive WIP. People get money for it. The service provider's business model is different than the owner's, right? The stage gates people think they're using and they're just getting blown out by other stakeholders, right? And you just got a perfect cocktail for what exactly we have going. So people love predictability. It starts with the CEO providing prediction to the shareholders. That rolls down to the people that predict to the CEO,
Yep.
so on and so forth. And we actually have built the ultimate model of predictability. Pretty much everything will run over time and budget because we designed it that way.
Yep.
And unless we make radical changes, I could predict most projects are going to have that kind of an issue.
Yeah, should be no surprise.
Right.
It's actually behaving just as the science said it would behave.
You're exactly right.
Yeah. So these production systems, once they're recognized that they exist, can be designed, can be optimized to meet the schedule and business demand. Is that where we're headed?
Well, that's really interesting. And you and I had the opportunity to go to a large American automotive manufacturer, one of the primary ones. And it took me, after leaving there, thanks for that trip, by the way, it took a couple months to figure out what was going on. And there's another profound concept here. And what we saw at the beginning of the day was the production engineering guys. Remember, we were sitting there marketing and the rest. And there's these guys that design production systems, production engineers, right? And it's interesting to sit there and think about that. They take a design and control model like any engineer would do. Then later in the day, we saw the lean guy. And the lean guy, he was responsible for doing lean around the plant. I was like, wait a minute, you got these production engineering guys doing this, you got the lean guy doing that. How does that work? Then it dawned on me, the big, heavy, 90% of it is true scientific engineering, operation science, production engineering, right? And then you tune it with the lean.
Mm-hmm.
And so what I see us doing in construction is we're just doing continuous improvement with lean when we really need to step back and take a production engineering design and control model. Now, I just like to add a little bit more on that and to take this back to what we were talking about earlier. One of the problems is I believe industrial engineering, where all this sits under, is probably it's one of the only engineering disciplines where you don't need a license.
True.
So anybody that worked at a company that saw somebody do something now becomes a consultant, and they're offering advice on how to go do lean.
Mm-hmm.
But this is far more complex, and if you don't have an understanding of the operation sciences underlying foundation, and you don't have the tools, it's so overwhelming you can't do anything other than have leadership meetings and so on and so forth, because it's too complex.
Mm-hmm.
It'd be like designing a structure using Abacus. Not that people didn't do it at the time, but it just takes a long time, right?
Yeah. So is there anything beyond production system design, optimizing, using the science, using the 5 letters? Is that the whole equation?
Well, I think what that does, and these are great questions. That now, if we can understand production, we can then start to apply modern technology, right?
Mm-hmm.
You go to LinkedIn, I'm just blown away. LinkedIn, I see these shops that these guys build, and there's a guy hanging off a ladder with a screw gun, right? And once you get done counting safety violations, you're thinking to yourself, why are you in the shop? So my buddy Mark Reynolds, the managing director of Mace, calls them builders and sheds, and it's a crazy thing. So you think about this and say, what can we go do, right? There's no reason, and we do this today at our company, is you could link GPS sensors from logistics equipment to give you a real-time feed. Mm-hmm. We could take IoT sensors, whether coming from concrete or whether give you a real-time feed, and we could feed forward and feed back, right? We could begin to bring in forms of automation to do work, because now we can control it in the context of when it needs to do the work, right? So I think what you have here is, as long as you're in administration, and I'm sure the next realm of technology and construction will be machine learning and AI and robotic process automation to deal with contracts and estimates and who knows what else, right? Maybe the Oracle Primavera Claim Digger will be an AI platform. I don't know.
Yeah.
Okay. But if you can move the conversation to production and you start to understand the workflows and the assets that are associated with it, that instrumentation is already starting to become there. I had lunch with a guy that runs a plant hire company in the UK, and he says, we have tremendous amount of information coming off of the equipment, rates of digging, how long things are running. I mean, he just says tremendous. He says nobody's interested. Nobody's interested. It's profound, right? And so we're talking about, well, how would we connect that? And again, what the vision here, and someone said the other day, I can't take credit for it, is schedule as dashboard. Maybe we don't create schedules anymore; they create themselves.
Wow.
Right? Because those production systems that are configured to the meta level production system of the project already exist. Right? They're already out there.
Right.
So we're plugging them together. So they already have what I would call the communications coming from the equipment. People are logging in using biometrics, and let's not forget the phone, right? And all that can be done with that. So no one's really stepped back and said, wow, we're collecting a lot of data. What do we do with it? It'd be interesting to know who's moving around the site for more than just a security and safety perspective, right?
Yeah, for sure. You meant you had a word in there. You said control. How do you control a production system? What's that all about?
Well, that we could spend some time on, but I would say this: control doesn't have to do with reporting. I think Peter Drucker said controls is not the plural of control, right? Controls has to do with what happened. Control has to do with what we want to have, making what we want to have happen. So I think the first thing we've got to do is understand what control means. All right, control is not reporting. We also need to understand that a schedule is probably the worst form of control, right? It's a push system, and we're trying to make things happen based on a predicted point in time. It's very, very difficult to do that. Really effective and efficient control systems could be like what Toyota did with their pull-based system, where the downstream is sending a Kanban cart up in a bin or whatever to send some more production down, right? Or what Mark Spearman had developed called the con whip, where the signal goes to the front of the line. And so control, probably the easiest way for people to understand it, is the thing at the airport, at the security scanning. That's controlling how big your bag can go in, right? A tower crane and how the schedule's allocated for the crane is controlling work on site. So typically, the way I find it in construction, the manufacturing of the line's a little different. If it's bothering you a little bit, then you're probably dealing with control, because you're not in control. There's a higher level of control. You follow what I'm saying?
Yep.
Right? So we always say there's 3 levels of control. There is physical control, right? The thing at the airport, or maybe the amount of trailers that you allow on a site, okay? There's software control, right? That we happen to be in that world, right? And then you have human decision-making control. And what we do in construction is we put about 90% on human decision-making. So we got Excel spreadsheets with trackers and so on and so forth, rather than having real control that can be done through other means.
Wow. That's insightful. So this is really interesting. And so I'm sure there's some folks in our audience that are asking themselves, okay, so I recognize the production system. I use the science to manage that production system. 5 levers, it's controlled differently. Does it give me the results? Does it give results? Different results.
Yeah, I think the results speak for themselves. We could start off with what happened at Heathrow Terminal 5, a very complex project. And just to give you some data on that, that was a delivery to site every 28 seconds, right? And the laydown on site was only today's work and tomorrow's, and that's it, right? So a complex and sophisticated logistics system was put in place. Some of the ideas there were putting the fabrication assembly work that was done offsite closer to the site, right? Controlling how things were flowing around the site, right? Real-time production control was developed for that. And then we fast forward to other projects where we're talking about vast oil field developments or LNG plants, and the list goes on and on and on. Turnarounds, offshore oil and gas projects. Because the gap is so big and the situation, we're built to fail. That's literally what it's about, right? We've built it to fail when you consider all the administrative stuff we have in place actually are creating the problem. And so when you address those, you get results. I challenge anybody, and I said in the book, I'll say it now, show me a project that we can't optimize, all right? I had a friend tell me the other day, he said, I've been playing around with this stuff. I think I'm gonna make a 50% margin on a project. That's unheard of in his business.
Yeah.
50%.
Wow.
Right? And so, what's the value? Well, the value is very significant.
Yeah.
Right? Very significant.
To all parties involved.
All
Not just
parties
the owner,
involved.
but the contractors involved as well.
So on that particular project, the contractor is going to do very well, the specialty contractor, and the owner is going to get their schedule accelerated.
Yep.
Right?
Yeah. Huge
Yeah.
for everybody. So this is so refreshing to hear. I mean, you've cracked the code on solving this age-old performance problem for projects, and well documented and built to fail. So where can folks get a copy of the book?
Yeah, so the book's available on Amazon, Barnes and Noble, right? Or a couple places. For a few, if they write us, sometimes we send them out once in a while. So if you see something out there, contact the Project Production Institute, and we've been known to throw a copy out there to people that are interested. But yeah, it's the book's going very well. I'm very surprised. The only negative comment that I heard about the book so far, and I agree with the guy, the graphics in the Kindle version aren't that good. And
they're not.
we're going to solve that problem, and we're loading all the graphics up on the Built to Fail website. But I'm trying to get a debate going, but it doesn't seem like anyone wants to debate. They all say, yeah, you're right on. You're someone had to say, you're right on.
Yeah.
So it's a little surprising to me.
Yeah.
I thought we'd be in about a 15 rounder by now, but nobody's coming. So now I'm just saying, tell me where there's a project that we can't sort out with Operation Science.
So our audience, bring it on.
Right,
You got
yeah.
one of those? Bring it to this
Yeah.
guy and see what he can do with it.
Absolutely. We've actually played around with a TV show. Like, we should go out to these
Yeah.
projects, right, and see what can be done.
Yeah, like
Right.
save the restaurant.
Yeah,
That's a great idea.
Yeah.
So I'm hearing rumors of maybe a sequel. Any truth to those rumors?
Yeah, we're thinking. Well, I was thinking that what we should do is probably Built to Succeed, right? Put a positive thing and talk about. You asked, right? So there's for me there's I don't know, over 30 years of success playing around with production. I shouldn't say play around, getting it sorted.
Yeah.
And so maybe we should have some success stories and go back and including Heathrow Terminal 5, where a group was
Yeah.
at a dinner the other night. And we're talking about maybe we should do some
And tell those
documentation.
stories.
Yeah.
Yeah.
And then along comes the guy that says, well, you really need to make a textbook so that they teach you stuff in universities, because we got to fix those guys coming out of school. And so I said, oh, that's a whole nother one. That's probably not, I'm probably not the best guy for that. Maybe that's, one of these guys that have a PhD, but yeah.
Yeah, that's serious.
We're going to do something though, for sure.
Good. So where do you hope to see things in 5 years?
I think if we can get people to see what production is and not what we want it to be for commercial consulting opportunities that people run around out there.
Yeah.
If we can at least see that there's a production system versus a schedule, and that you can use things like Operation Science to understand and optimize those production systems, that would be a huge step. And to be honest with you, and to be perfectly blunt, I like to eradicate a bunch of these guys that are out there going on about stuff that don't know what they're talking about, because I think they're dangerous.
Yeah.
Right?
They are dangerous.
Yeah.
There's no doubt about that. It's a blind leading the blind.
Right.
Yeah. So I just read your book. I want to know more. I want to go deeper. What do you suggest?
Two things. If you're still hanging at the strategic level, I'd visit the Built to Fail website, right? And we could provide that address. And then for people that want to get deeper, I'd go to the Project Production Institute and see what you guys are doing over there, which is absolutely amazing, and really drill down as far as you want to drill down, and all the way into the mathematical equations with the Operation Science to people that are really doing things. I think those are probably the two protocols where I would go.
Excellent advice. Yeah. So Todd, how can Operation Science assist us in understanding what might happen on my project?
Yeah, that's interesting. It's something that we've got more and more involved in and spend a lot of time thinking about. So if we could bifurcate the schedule from the production system, and this alone is very interesting. If you take the schedule and you look at even a resource histogram that the schedule shows versus the production system are very different, right? And like we always say, and I'm hoping people can get their head around this over time, it doesn't matter what the schedule says, the production system will dictate what's going to happen. Okay, so if we could see the production system and the production system is going to dictate what's going to happen, then we can take and we can model that production system. We can analyze it using mathematical equations. We could run simulations and begin to understand what's going to happen from a highly reliable perspective. So highly reliable prediction. We actually now can bring a crystal ball, as crazy as that sounds. But we got to focus that not on the schedule. The schedule's the demand into the production system. We have to model, analyze, and simulate the actual production system itself. Now, a lot of people, when I was on the phone with a guy the other day, said we already do that with our critical path schedule. And fortunately for me, I was on the phone with one of the people that work for one of the leading critical path scheduling software, and he said, well, that's not what we do, that's why we're together. So there's people that argue that, but the reality situation is, again, if we can bifurcate the schedule from the production system, we can apply the production operation science to the production system, we can now come up and use analysis and simulation to get very reliable prediction as to what's going to happen with regard to time, which owners care a lot about, and cash flow. We could identify where unnecessary work in process is building up, where we have excess capacity. We can remove that, and every time we remove that, we're removing cost and time.
Yeah.
Right? And cash. And one of the things that we don't talk about is cash. So, I'll give you, for instance, a project manager will say, what does it matter if I buy the stuff now or later? I got to buy it anyways.
Right.
Well, to you, it doesn't matter. It's probably a good idea that you should go buy it. However, if you're the business, that project manager is removing cash, or I'd say re-engineering the balance sheet, taking it from the cash position and putting it down there in the inventory position. We want to identify where we're doing that, right? Because that's actually changing the investment thesis of a project.
Sure.
And a company when
Yep.
you get to capital intensive industries.
Yeah, it changes the ROR for that project or return on capital employed for the company.
Because you might not be able to do another project.
Exactly.
Right.
Ties the cash up.
Yeah.
Yeah. Very good point. So Todd, you're a real supporter of the Institute's work around trying to educate people in these principles, and through some formal partnerships we have with universities, and then our annual symposium. What's your view on that?
Yeah, so I think that there's probably three people out there. You have one individual that just wants to put their head in the sand, doesn't really care about this.
Yeah.
You have other individuals that really need to go do something, right? And for those people, they have a problem to solve. They might need to bring in someone that they could work with. Maybe, hopefully, maybe they call us at SPS. I don't know. But the third person is one that sees this as an educational opportunity, and it is. Mm-hmm. And you probably need option B and C. The educational opportunity is significant, and when you guys put these partnerships together with Texas A&M and Stanford, I mean, these are Stanford's the ground zero, right? And Stanford isn't for everybody, and either's TAMU, right? But it's a great two options for people to go and become immersed and actually work on this stuff. Now, I know you guys have worked really hard, and I hope people understand this, to not have lectures.
Yep.
Actually go do work, right? And to go to those programs, one's a little bit different than the other, but the same concept, if you will, technical, to take your project there, take your team, and go work on a specific item. And so, you think about the investment to go to one of these courses, and you probably could save yourself, I don't know, 40, 50 times the investment just solving one problem on a project. It's incredible, right?
Yep.
So again, what PPI has done with Stanford and with TAMU is just incredible, and I think that I would encourage people to go. The other thing is, if you really want to dig in and say, maybe you're not even ready for that, you just want to hear what's going on around the patch, then each year PPI does the symposium, and this year typically it's in December. That might be a good option as well.
Yeah.
Right.
Excellent. Well, Todd, thank you for giving us your time so generously and sharing many, many, many years of hard-earned wisdom and insight for project folks who want to do something different and remove the pain and have successful results. So thank you very much.
Thank you, Gary, for the
all
opportunity.
your
And thank you for
contributions.
excellence. Thank you.